It's me again, mass, weight, and gravity calculations. You all did the assignment either with me or with Mr. Nippard on mass, weight, and gravity. So just before we get moving too far ahead, we have to make sure while you're trying to do your culminating that everybody has their formula sheets it's a two-sided sheet that looks like this. Okay? If you don't have one, ask your teacher for one. And you might need the sheet that was given out with the mass, weight, and gravity assignment. It was part of the assignment that shows the newtons per kilogram value of gravity on various planets. Okay, so let's have a look at our mass, weight, and gravity calculations using once again our triangle, where again the line here is divide and here it's indicated as multiply. Okay, so Leslie is an astronaut on a new planet. She knows her mass is 70 kilograms, so we'll write down mass is equal to 70 kilograms. And she can calculate her weight on the planet to be 512 newtons. Remember, weight and force are always in newtons. What is the acceleration due to gravity on the new planet? So when they talk about the acceleration due to gravity, we have to remember that gravity is a force in motion, and therefore some people will refer to it as a rate of acceleration, which is really what gravity is. Okay, but we'll keep it a little simpler than that, so we're trying to find g here. So we cover up g, and we see that gravity is always equal to weight in newtons divided by mass in kilograms. And we're trying to come up with an answer in Newton kilograms. So in this case, you're going to have a weight. So, gravity is equal to weight divided by mass. So in this case, you're going to have 512 newtons divided by 70 kilograms, which is going to give us 7.3 Newton per kilogram, or newtons divided by kilogram if you really want to get fussy about how you write it down. So in this case, our answer is 7.3 newtons per kilogram. Okay? That's how we solve that. Let's have a look at the next problem. The mass of your new motorcycle is 250 kilograms. What is its weight on Earth in newtons? So we have a mass of 250 kilograms. Weight is a question mark. But what's the force of gravity on Earth? Well, now we have to go back to our chart that we were given, and you'll always be given this. And we see that Earth is 9.8 newtons per kilogram. So G is equal to 9.8 newtons per kilogram. So then if we're going to find weight, we cover up our weight. And it's mass times gravity. So W is equal to mass times gravity. So in this case, that is going to be 250 kilograms times 9.8 newtons, which really we can write it this way now, kilogram. And that's going to give us 250 times 9.8, 2450 newtons. Why newtons? The kilograms cancel each other and we're left with newtons. So our answer here is 2450 newtons on Earth. So what's its weight on the moon? Well, it's the same problem, except for now we're going to have a different outcome. 250 kilograms is still the mass, but the force of gravity this time, if we go back to our sheet and we're looking for the moon, which is listed as a satellite, is 1.7 newtons per kilogram. So our weight is going to equal mass times gravity. So it's going to be 250 kilograms multiplied by 1.7 Newton kilograms, which is going to equal something different this time. 250 times 1.7, 425 newtons. Okay, once again, the kilograms cancel each other, and you're left with newtons. Now, the last part of this question is kind of a trick question. It's asking, what is the mass of the motorcycle on the moon? Well, something to remember in these things, mass, when you're figuring out these problems, put a note right on the sheet, mass never changes. Okay? So an object's mass is constant. Okay? So when you get a question like this on the test, that's like a gift. The mass here is obviously going to be 250 kilograms because it doesn't matter where in the universe this thing goes, it's going to have a mass of 250 kilograms. Okay, guys, I hope that helps everybody study. We'll move on from here.